once again. Welcome to another session of our class learning area. Today we'll be treating vectors. Yeah, a student requested for a video on vectors. He asked us to explain how vectors are done and as well as the calculations involving vectors, so he'll be able to understand vector representation. Now, first of all, where did vector come from? Now, vector has a twin brother, or not a twin brother, an opposite called scalar. An opposite called scalar. Now, they are both from measurations. They are both from distance from measurations. Now, vector and scalar are two different terms. When a particular quantity, whether in mathematics, physics, or chemistry, or whatever, has both magnitude and direction, we term it a vector quantity. Now, for instance, we can say the boy is running towards the gate. Now the boy is running towards the gate. Now I've told you the boy is running, and that means the boy is carrying that a particular distance, and I've given you the direction the boy is going to towards the gate, so automatically it becomes vector quantity. When I say the boy is running, I did not tell you the particular direction with which he's going to, but I told you the magnitude that the boy is actually running, probably at a particular velocity or a particular speed or whatever, but I'm not giving you the direction. That is scalar. So when you have the magnitude and direction, it becomes a vector, and when you have just the magnitude, it becomes a scalar. So for instance, we can say the force of the body is 20 newtons due east. This becomes a vector quantity. But when we say the speed of the body is 30 meters per second, finish. That is just scalar. There is no direction there. So vectors has to do with direction and magnitude, while scalar has to do with just magnitude alone. So how do we solve for vectors? First of all, vectors are represented using this particular arrow. So for instance, I can say vector A will give us xi plus yj plus zk. Xi plus yj plus zk. Now, this is the magnitude of the vector A, x, y, and z. While I, j, and k are their respective directions. So we have magnitude and direction, magnitude and direction, magnitude and direction. That is for vector that. Now, there are three types of vectors. The first one we have the free vectors. Now, these free vectors, they are just vectors that have the magnitude and direction, but they are not defined. Their distance are not defined. We just know they are vector because they have a particular magnitude and direction, but not a specific distance. The second one we have the localized vectors. Now, for localized vectors, we have a particular position. So we know it is from position A to position B, or from position B to position A, or maybe we just have it as that 8 Newton. That becomes a localized vector. But when there is no particular, starting from 0 to wherever, it becomes a free vector. This becomes a localized vector. Then the third one is the
co-initial vectors.
the
Co-initial vectors.
vectors. And these vectors are the ones that meet at a point or start at a point. So a particular point, we have vector A going, we have vector B going also, we have vector C also, and continuously and continuously and continuously. Now they all meet at a point. Either they are coming towards the point in this particular direction, or they are leaving the point. They become
co-initial vectors
because they are coming and they are meeting at a particular point. So these are the three types of vectors that we have. So like I have said, this is how vectors are represented in this particular form. So they can say a vector x is equal to 2i plus 3j minus 5k. This is how they will represent the vector for you. It can be vector s, it can be vector ab, but whenever you see this arrow on top, or maybe just a dash on top, you know they're talking about that vector quantity of that. It may be just 2, maybe 3j minus 5k, or it may be just 2i minus j. Whatever it is, in as much as they show you that this is having a magnitude and direction, automatically becomes a vector. So somebody will be asking, how do we add and how do we subtract vectors? It is very easy. It is very easy adding and subtracting vectors. Now, to add and subtract vectors, this is just what we do. Now, for instance, we have a vector x to give us ai plus bj, and we'll have a vector y to give us ci plus dj, and we're asked to add to find x plus y. What you simply do is you add the vectors in the same direction. So which of them are in the same direction? I and I are in the same direction. So we add a plus c. So it means that x plus y is equal to what? A plus c, the same direction of I, plus what? B plus d, the same direction of j. So for instance, we have vector p is equal to 3i plus 2j minus k, and vector q is equal to I minus j plus 2k, and we're asked to find p plus q. We're asked to find vector p plus vector q. What it means is we have to add the same quantities in the same direction. So we have 3 plus that, we have 3 plus 1 I plus 2 minus 1 j, 2 minus 1 j, then plus that is minus 1 here, plus 2, then k. This is minus 1, this is minus 1, that's why it's minus 1, this is minus 1, that's like that. So 3 plus 1 gives us what? 4i. 2 minus 1 gives us what? 1. Then minus 1 plus 2 gives us what? 1. So that is our addition. The same thing happens for subtraction. If for instance we add to subtract that, we have p minus q is equal to what? 3 minus 1 I plus what? 2 minus 1 j, 2 minus 1 j, then plus we have that as minus 1 minus 2k. So 3 minus 1 gives us what? 2i, plus 2 minus 1 gives us what? Plus. So 2 plus 1 gives us what? 3j. Then we have minus 3k. So that is for that. That is for addition and subtraction. When it comes to multiplication and division, there is a certain formula you apply. Now, if you want to know the formula we apply, check out our next video on vectors, where we explain how to do addition, how to do multiplication and division of vectors, for you to be able to understand fully how to apply that. So thank you very much, and see you in our next class.